the notes for 5.1. I am going to warn you, you're going to be using the back of this page to finish the last example. It is a very long one. Very, very, very long. In today's examples, we're going to be talking about declining scales, or things that are getting smaller. Manufacturing company notices that its sales have dropped from 100,000 knits per month. That's supposed to be units, not knits. I apologize. Throw a U in here. Units per month, not knits. To 80,000 units per month. They lost 20,000 units. Okay? If the sales follow an exponential pattern of decline, what will they be after another 2 months? So we're talking about that proportional formula once again. We're talking about that y equals CE to the KT. Okay? We know a couple of things. We know that C equals 100,000 when T equals 0. Okay, it's what it started with. It was its constant. We know that Y became 80,000 when T equaled 4. All right, so we know that we can kind of fill out $80,000 equals 100,000 E raised to the 4K. Talking about the 4th year. We know that it dropped from 100,000 to 80,000. When we do a little math here, we get 0.8 equal to e to the 4k. Or if we raise everything to the ln, we get the ln of 0.8 equals 4k. And since ln of 0.8 is actually a number, guys, you can put that in your calculator and get a decimal approximation. When divided by 4, k approximately equals negative 0.0558. Okay, so now we know what a couple of things are. Okay, we knew our was our c because that was our constant. That's what we started with. So we can, when we're talking about when we want to know when t equals 6 because it's after 2 months, we can write the equation y is approximately 100,000 times e to negative 0.0558 times 6. And when we put this into a calculator, we get approximately, again, this is not 100% accurate, this is approximation, we get 71,500 units. So that is what, all right? So we took our 100,000 and we made the C because that was our amount. That wasn't, that was staying where it was. We made Y 80,000 down to after 2 months. Not in years, not in days, but in months. Okay, it most likely would change for each question. All right, Newton's law of cooling. This is a long, small picture of an object in a room whose temperature is kept at a constant 60 degrees. If the object cools from, that should be from, not form, sorry guys, 100 degrees to 90 degrees in 10 minutes, how much longer will it take for its temperature to decrease to 8? All right, well, here's what we know. We know that between 80 and 100. Okay? We can rewrite this as dy dt equals k times y minus 60